we started looking at area, and we looked at a few different shapes, right? We looked at 4 of them. Do you remember what they were? What did we start with? We started with squares, right? And then we moved on to rectangles, then triangles, and then we moved on to parallelograms. Unfortunately, someone has some extra memories. I don't know if someone's messed with you. We did not look at trapeziums. We will next week though. So I want to call your memory back to, in particular, the parallelogram. Okay? Have a look at it. Now, can you remember how did we work out the area for the parallelogram? We had to play a bit of a trick with it, right? What did we do? Do you remember? Okay, sorry. Let's come back over here. Let's see if we can remember. Let's see if we can recite area of a square. If the sides are all like S, what was our formula? S squared. Very good. If you've got length and breadth, then your formula for the rectangle is length times breadth. If you've got the base and the perpendicular height of a triangle, then what's its area?
Half BH.
Half base times height, or base height times on 2. So I'll write it over here. Okay, and then we came to the parallelogram and we said, I can't divide it up into rectangles or squares, right? I had to do something else with it. Who can remember? Nathan, you had your hand up?
I can't remember the formula, but like with the line at the end where it's like where the triangle starts sort of thing.
Okay, hold on. Let's take that idea and see if we have language that can better describe this, right? The reason why, like maths and every other subject out there invents new words is because of the exact sentence that just came out of Nathan's mouth right now, which half of you knew what he's talking about, and the other half of you do not, okay? So let's try and take those ideas. You said to put a line somewhere over here. What kind of shape am I going to make? I'm going to make a triangle. Not just any triangle though. What kind of triangle do I want over there?
Right angle.
Right angle, very good. So, I want 90 degrees there, right? Which means that blue dotted line I just drew, it has a particular name. Starts with an A. Something that we use to describe when, planes are in the air and we say how high are they, right? It's altitude, right? So you've got this altitude here. Creates a new triangle, right? And then what did we do with that triangle? We moved it over, didn't we, okay? We moved it round to this side, okay? And this was the shape that we ended up with. Okay, does that make sense? So we lost this triangle over here, and we gained this one, and then haha, magic, it's rectangle. And the point is that what you did in the first place was you considered one shape as a bunch of other shapes, in this case 2, and then you could shift them around, okay? So what we did was we considered the area of what we call a composite shape. It's a shape that's divided up into other shapes, okay? And that's what you're looking at with the sheet in front of you. Now, these are not hard. All of the shapes that I've given you are some combination of these 4 shapes. There'll be squares, rectangles, triangles, or parallelograms, okay? Or they'll be kind of like rectangles take away squares, or triangles take away rectangles, or some other kind of combination, okay? So I'm just going to go through one example, show you how not to do it, and show you how to do it, and then the rest of them you can have a go at on your own. Does that sound all right? Yeah. Cool. In your books, I'd like you to start by having a look at 1A with me, which you already should have done when I was walking around. Let me start by showing you how not to do it, and I'll get my red pen out so you can see what I'm going to do. Okay, so 1A, here's what I'm going to write down. I've got 10, 12, 18. That looks to me like 10 plus 30, which is 40, and it's an area, it's in meters. Ta-da, there's my answer. Okay, part B. So this is how not to do it, right? Now there's a lot of things wrong with this, apart from the fact that the answer is wrong. But I want to unpack why it's wrong, and what we can do to improve it. Okay, suggestions. Okay, all right, so the first thing that's wrong is I've added these things up together. If it's an area, what am I going to have to do instead? I'm going to have some multiplication, just like here and here and here. Okay, so that makes sense. So for starters, this is the wrong process, okay? But further than that, even if we had the numbers right and the multiplication right, if this is wrong, you have no way of really determining why it's wrong because there isn't enough information here. Okay? Now, I know I've supplied diagrams to you, but I would like you right now to draw your own diagram. Make it a bit bigger than this one so that we can put a bit of information on it. Okay? And I'm going to do the same. So draw it with me. Okay. Now, here's the first step. Here's the first way to make sure that we're going to get this right. Okay? They very conveniently divided up this shape for you. They won't always do that. You'll sometimes have to work out how to divide it yourself. Okay? But being that they've done it for us, let's now label these areas. I'm going to call this one Area 1 and Area 2. If you wanted to, you could call it, area of this rectangle over here and area of this triangle. Okay? But sometimes it's not quite so obvious which one's which, or maybe you've got a whole bunch of rectangles and you don't want to say area of this rectangle and area of that rectangle. If I've got numbers, it's completely unambiguous. So, let's have a go at Area 1. Area 1. Okay? So it's a rectangle, so which formula am I going to use?
Half. No.
Oh,
Length
rectangle, sorry.
Length times breadth, right? Length times breadth. So I've got a length here and a breadth, so 10 by 12, very good. So it's 120 and it's an area, so meters squared. Okay, so I've worked out my first one. Now I work out my second one. Okay, let's try someone else, Nathan. It's a triangle, so which formula are we going to use? Jacob?
Half.
Okay, half times base times height. Now, hold on a second. I don't actually have on there what the base is, right? Because in another color, here is the base, but I don't have a number just on that. How are you going to work it out, Amy?
Oh, 18 minus 12.
Fantastic. So you can see you've got to use the information on there to work out what you need. And 18 minus 12, of course, is 6. Okay, so there's our base. Right, Nathan.
Wait, if we were to find the hypotenuse, would we do 6 squared plus 10 squared, which equals hypotenuse?
Squared?
Yeah.
Yes, that's how you would work that out if you wanted to. Though keep in mind, being that we only need the base and the height, which we already have, in this particular case, you won't need the hypotenuse. I guess if you wanted the perimeter, you would. Or if it was a different kind of shape, that might be useful to you. So that's how you would do it. Okay, half times base, which you just decided, times, and it shares the same height as the rectangle. Right? So that sounds like 30 to me. Okay, done. So now we can write the total area, which is of course 1 plus 2, which is 150. Okay, now in this particular example, okay, because it starts off pretty gently, you probably could have gotten away with, honestly, just writing down the numbers and then ending up with your number, okay, your final area. But as you can see, if you cast your eyes down the sheet, that kind of approach, without describing what's happening and labeling and all that kind of thing, is going to become less and less reliable, okay? You're going to forget areas or get the dimensions wrong, all those kinds of things. If you have your whole working written there, then you can make sure it's right. If you have an error, you can trace back to where it happened, rather than just like, my final number's wrong, don't know why it's wrong, guess I'll just move on, okay?